All right, so this video that you're watching right now is only 4.4b, but it is specifically the end problems where I'm going to do this train distance equals rate times time. And then I'm going to do these two problems on the back, which are compound fractions, and it's basically getting rid of the denominator and simplifying. So we're going to start here. All right. And here we go. So distance equals rate times time is what's happening here. And we're going to look at this and figure out like what we need to solve for. So Leah drives her car to the mechanic. Then she takes the commuter train back to her neighborhood. The average speed for the 10-mile trip is 15 miles per hour faster on the train. So obviously the train goes faster than a car. She drives her car to the mechanic, and then she takes the train home. The train goes faster, so there's 15 miles an hour added to the car. We don't know how fast the car was going. Find an expression for Leah's total travel time. How long did this take? So I am going to organize it really nice with this chart. The distance that the car, okay, look at the 10-mile trip, all right? So it's a 10-mile distance, all right? So the distance that the average speed for the 10-mile trip is 15 miles per hour faster on the train. So that means that she was going to go in her car, she drove 10 miles, and the train ride was also 10 miles. So the distance for both of these, the car and the commuter rail, is 10 miles. Okay, the rate. It says here in her little car that the speed, which is rate, we don't know. Unknown. That's our variable. And the train goes 15 miles an hour faster than a car, which makes sense. Trains go faster. So my car tells me my speed is just R. So put R there because we don't have an actual like miles per hour. And the commuter rail speed is R plus 15. Now, we're solving for time. We don't know. Which means T, I'm going to translate distance equals rate times time, and I'm going to isolate T. I'm going to solve for T. Yeah.
Don't we know that she drove 30 miles per hour?
Oh, if she drove 30 miles an hour. Yeah, we're going to plug that in first. We're going to write our expression, and then we're going to plug the 30 in. Yes. Okay. The time is going to be, solve for time. That means I would divide R, both sides. D divided by R. I should put that a little better. T equals D divided by R. That means over here, D divided by R, I'm going to need to write 10 is the numerator, R is the denominator, right here for car. 10, D over R. I don't know how long she sat on her trip. 10 in the numerator, R in the denominator. And I got that because I had to manipulate the formula to figure out the time. 10 divided by R, and then 10 divided by R plus 15. Okay. Car plus train. Car, 10 over R, plus train. Train is 10 over R plus 15. Remember, the question says, how long? I don't know. So that's why I had to have this unknown time, and I manipulated these two numbers, maybe the fraction, 10 over R, and then 10 over r plus 15. So I am now saying the total time that the car spent plus the time that the train is the trip, is the whole trip. Okay. Now, sad news, if this were my addition problem, I don't have a common denominator. I can't add this. So how do I add this? Find LCM, which is the denominator. What's the common denominator of an r and an r plus 15? Yeah, both of them, r plus 15. So now I'm going to go car, r parentheses r plus 15, plus train, new fractions r times r plus 15. Okay, well, I have to figure out my new numerators. Started out my fraction with just an r, but since my denominator is r and r plus 15, I need to multiply top and bottom by r plus 15. 10 r plus 15, because the 10 was already there. And this 10 was already here. Second fraction, I have a denominator of r plus 15, but the new denominator is r plus 15. So what am I multiplying top and bottom by here? R. 10r. This is my new fraction. I'm going to distribute and combine like terms. 10r plus 150 plus 10r over r plus 15. So it says find an expression. First thing, find the formula. 20r plus 150 divided by r plus 15. Then, if she drove 30 miles an hour using 30 mph, now I'm actually going to plug in 30 instead of r because that's my rate. 20 times 30 plus 150 divided by 30 r and then r plus 15. Okay. 750 is my new numerator divided by 1350. Final reduction is 5/9 of an hour. That's 33 minutes. And you would translate 5/9 and be like 5/9 times 60 minutes. That's how you'd figure out 33 minutes. Or you could divide 60 minutes into 9 parts and then find 5 of those. Lots of options. So, distance equals rate times time, using a chart to keep yourself organized, and knowing what it's asking. I didn't know the time, how long. So that's why in this chart, my time was really important for me to use distance divided by rate. Okay. All right, so now we're going to finish off 4.4b. So this is the end of 4.4b still. And I have 2 problems where I am simplifying a compound fraction. So here's what I need to do. I need to simplify the most complicated portion. That means, is the numerator really need to be simplified, or does the denominator really need to be simplified? So right now, I cannot do this math problem unless I find and make one fraction out of this numerator. This 2 fraction thing here, that's going to be complicated for me. So I'm going to find the common denominator and just focus right now on the numerator. So I'm going to simplify the numerator first. So I can do that over here. 1 over x plus 2 over x plus 1. Let's get the numerator simplified. Okay, what's the common denominator of x and x plus 1? X parentheses. Yep, you are right. So I made my new fraction with my new denominators. Okay, x is the original denominator. I need to make it an x plus 1. Multiply by what's missing on top and bottom. X plus 1 is missing. The second fraction had a denominator of just x plus 1. I need to make it x plus 1. What's missing? Just the x. Two times x, 2x. Okay. New numerator, 3x plus 1 over x plus 1. So 3x plus 1, I'm going to write it on top, over x parentheses x plus 1 divided by 1 over y. So what I did right here is I fixed this numerator. It was too busy. I needed to add them. I needed to find the common denominator. And I got this. Here's the work to show it. Now, I have to simplify this. I've got a single fraction over a single fraction. Much easier. A single fraction over a single fraction. I want to get rid of the denominator. I'm pretty confident I've showed you before problem like, sorry, I really shouldn't be standing at the board. 1/2 divided by 5/8. What did I do to simplify this problem here? Multiply by the reciprocal of the denominator. Yep. So I'm going to, step 1, step 2, multiply by the reciprocal of the denominator. I want to denominate, what? Why does that look so wrong? Denominator. All right. Reciprocal, y over 1. Y over 1. Multiply top and bottom by the reciprocal. I'm going to get, so I don't want to distribute it. Honestly, the best way to do it is, okay, so this cancels out, right? Gone, 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 gone. Nothing's in the denominator anymore. So here, I'm just going to put y in the numerator, and then I'll put 3x plus 1. I'll put it in parentheses because I don't want you to distribute. The denominator is going to stay x plus 1. So I just put the y in first. This is the most simplified form. You cannot cross out this right here. They look close, but they're not exactly. Okay, so that's example 4. I had to work out the numerator because it was super crazy looking and it wasn't simplified. Now the problem lies with the denominator on example 5. That's too busy. I'm going to simplify the denominator. And I'll do this work over here. Find the common denominator of 3 and x minus 1. What's the common denominator of 3 and x minus 1? 3. X, yes. Good. Now, edit. This started out as a 3, and now it's 3x minus 1. Multiply this bottom and top by x minus 1. I would get, what do we know about x plus 1, x minus 1? Difference of two squares, x squared minus 1. Okay. Now I have an x minus 1, and I need to make it a 3, x minus 1. Multiply bottom and top by 3. Okay. My denominator now is x squared plus 11 over 3 x minus 1. So, my denominator is now x squared plus 11 over 3 x minus 1. My numerator is 1 x minus 1, what it was originally. So this is new. I just did all that work. New denominator. I had to add them. Questions so far? Yeah.
For the x minus 1 in the numerator, why don't we simplify the difference of squares and then cross out the x minus 1 in the denominator?
Well, because I'm going to, things will be crossed out, but I have to multiply by the reciprocal first of this denominator.
Oh,
So I'm going to multiply by the reciprocal of the denominator because I need to get rid of the denominator. But you'll see it will cross out. Multiply top and bottom by the reciprocal. So simplify the denominator and then multiply by the reciprocal of denominator. Okay? All right, here we go. Down here, I'll use a different color. In the denominator, this all disappears, right? All I care about right now is this. 1 over x minus 1 times 3 x minus 1 divided by x squared plus 11. That's what I'm doing now. Now we get to cross out this x minus 1 diagonally. Gone. Only thing on top is a 3. The only thing on bottom is x squared plus 11. And that's your final answer for example 5. So we just finished 4.4b.